But where did organic molecules come from? We don't have a definite answer to this question, but we will learn about three hypotheses that scientists can test: arrival on Earth from space, formation on Earth through chemical reactions in shallow oceans, and formation on Earth through chemical reactions near hydrothermal vents. The dust in the solar system from which Earth formed was rich in organic chemicals. Meteorites striking Earth would have hit with lower velocity since the atmosphere was thicker. The monomers would have survived. Click to watch a video about comets and early Earth. We find organic chemicals in old meteorites discovered even today, such as this one. It's estimated that several million kilograms, or 5 million pounds, of organic chemicals fall as cosmic dust to Earth each year. Two scientists, Oparin and Haldane, proposed in the 1920s that the organic chemicals that form the basis of all life could have evolved in Earth's early atmosphere. In 1953, Stanley Miller used Oparin and Haldane's original idea and tested a hypothesis involving an artificial mixture of inorganic molecules while simulating the conditions thought to be found on primitive Earth. Within days, the experiment produced some of the 20 organic monomers presently found in organisms, as well as other organic molecules. Click here for an explanation of Stanley Miller's experiment. The primeval sea is a flask of warmed water. The early atmosphere was a mixture of water vapor, hydrogen, methane, and ammonia. The energy source was electrodes discharging sparks into the gas mixture, simulating lightning. A condenser cools and collects water and dissolved chemicals. And at the end, organic monomers were found. Subsequent work found some defects in Miller's work, but have produced, with experiments that took into account new information about early Earth, most of the naturally occurring organic molecules, validating Miller's hypothesis. The organic molecules found include amino acids, sugars, lipids, and nucleotides. Experiments like these are also significant because they show that scientists can test hypotheses about things that happened long ago, and they can build on and correct previous experiments. Recent experiments support a third hypothesis. Hydrothermal vents are found in the deepest parts of the ocean, where the crust is not thick and magma flows close to the ocean floor. Hydro means water. Thermal means heat. A vent is like a chimney. It lets gases escape. These vents are found 2,000 to 8,000 meters below the surface of the ocean. Hydrothermal vents spew hot chemicals from the Earth's dynamic crust into deep ocean waters. They're underwater volcanoes. Chemicals coming from vents include methane, ammonia, and metals that can act as catalysts. Chemicals in the water include CO2 and H2. The combination of these chemicals, catalysts, heat, and time could have supported the formation of organic molecules such as amino acids. Very rich communities live around hydrothermal vents today. The communities depend on bacteria that use the vents as their energy source. Recent data show that all living things may have come from hydrothermal vent bacteria. Scientists have many ideas about how life may have come from non-living chemicals. How do we know when something is alive? As we've already learned, all living things can reproduce, can transmit information, have an enclosed metabolism, and can take in and process energy, and are made of cells. So how do we get from an ocean of chemicals to living cells? The following steps may have taken place near hydrothermal vents on the ocean floor over a period of 700 million years. Number 1. Organic monomers formed spontaneously. 2. Monomers combined to form organic polymers. 3. Some of these polymers were RNA molecules, which could make copies of themselves and reproduce. 4. Polymers used energy and material from the vents to carry out metabolic reactions. 5. Cells formed by using lipid membranes to enclose RNA molecules and metabolic pathways for processing information and energy. All cells came from the first cells that formed in this way.